In this video, I'll be demonstrating the use of ISOLDE's adaptive distance restraints to reinforce the local geometry of a protein complex during a major rearrangement. This case study is built into ISOLDE as a tutorial. We start with a model of the ATP-bound state of a transmembrane complex superimposed on the 4.1 angstrom map of the ATP-free state. With the model this far from agreement with the map, an unrestrained molecular dynamics fitting simulation would quickly fall into a tangled mess. To avoid this, we use the ISOLDE restrain distances command to individually restrain the two main halves of the model to their original geometry. This sets up an extensive network of restraints throughout the model. Taking the first three heavy sidechain atoms of each residue, each atom is restrained to others within an 8 angstrom sphere. These restraints are adaptive in the sense that they only restrain strongly when the interatomic distance is close to the target, so that conformational changes may still occur where needed while still maintaining local geometry. For initial bulk fitting tasks like this, we are not yet interested in the atomic details. In order to more clearly see and guide the progress of the fit, we can reduce the display to a C-alpha trace by hiding all atoms other than the alpha carbons. In this starting configuration, the two chains on the right are a very long way out of the map. While given sufficient time, the simulation might settle to convergence on its own. In most cases, it is much faster and more sensible to guide it with some judicious tugging. Using ISOLDE's tug selection mode allows us to spread out the mouse tugging force evenly over all atoms in these chains. Rather than using a single continuous tugging motion, in most cases it is more sensible to tug in short bursts to guide the simulation towards the target. As it approaches the correct local minimum, it is typical to see it satisfyingly fall the rest of the way into position. About 2 minutes into this real-time demonstration, the task of overall gross fitting to the map is done. While there is still much to be done in terms of improving the details, that is beyond the scope of this video. However, let's take a quick look at what's been happening down at the ATP binding site while we've been busy refitting the other two chains. The original model was captured in the ATP bound state, where these two helices were pulled close together. On removal of the ATP, this pocket opened substantially. The restraints highlighted in purple have been strained beyond the harmonic region and are now pulling only weakly. Where a set of restraints is in clear disagreement with the experimental data like this, it is sensible to selectively remove them entirely. This can be achieved using the ISOLDE release distances command.